Okay, today we're looking at anti-differentiation. So it's actually the process of where you've been given the derivative or the formula for the gradient, and we want to go back and find the actual function or the original formula. So if you have a look here, it says the general antiderivative of 2x. So that would be here is the dy dx. And if you go backwards, it would have been, the formula would have been y equals x squared plus something else, where c would have been a real number, like a whole number, because when we find the derivative, we lose that whole number. So when we go backwards, we have to remember that was there. So we use set notation. So if you look here, they'll say find this symbol, this funny curve means the antiderivative. So they want you to find the antiderivative of 2x. So they're pretty much saying that's the derivative, but you've got to go back, and then there you can write that x squared plus c. So often we don't know what the c was, so we can just leave plus c, and we say c was a real number. So calculating the antiderivative, so you will be given a term and so we look there and we say, like, this term, so up there in the 2x, it has a power, so it's actually 1 up there. See up here, it'd be power, so this is the power. And the way you find the antiderivative is you add whatever the power is, you add 1. So because that was up here is the 2, it was 1, you add 1, so 1 plus 1 is 2. And then you divide down here. So you pretty much, so what we do, we first raise the power of the term by 1. So that's the opposite to which is good, opposite to what we do for the derivative. And we divide, remember we normally times, but here we divide by the term, which is the power, divide by the term, the power plus 1. Okay, and if we need to find c, we use, they'll give us a point, and we'll find that, and you'll see that in a minute in the examples. Okay, so with these examples, they find the general antiderivative, or is the rule or the function, whichever way you want to look at it. Okay, so we've got 3x to the power of 5. So this is the dy dx, that's the derivative. Okay, so if we're going to find the rule, what we do is we're going to have 3x, we're going to raise that power by 1, and we're going to divide by that new term, the 5 plus 1, and we can't forget that there was a plus c. Okay, so then we keep on tidying that up. Okay, so that will give us y equals 3x to the power of 6 divided by 6 and plus c, and we can simplify that because 3 over 6 is a half, so I can just write it as x to the power of 6 over 2 plus c. So that's my final answer for the derivative. Okay, so let's do the next one. So remember, this is dy dx, and we're going back to the function, so what y equals. And like when you find the derivative of each term, you find the antiderivative of each term. So this first one's going to be 2 plus 1 divided by 2 plus 1. Then I'm going to take the 4x, going to raise that power by 1 and divide by that 3 plus 1. And then also, we're going to raise this 3. It's got a 0 power, so now it's going to become, it'll be raised to x, won't it? Because it had 0, so you add it to 1, and then it'll be divided by 1. So just be careful, because that was 0. So then we've done 0 plus 1. Well, it's actually, so that was actually x to the power of 0. So you've done 0 plus 1, and you get the 1 here and 1. And then we can't forget to do c. So we just tidy that up, and you get 3x cubed over 3 plus 4x power of 4 over 4 plus 3x plus c. And obviously you can simplify this first and second term to be like that, and 3x plus c. So that's your final answer for that one. Okay, in this question, it is known that f dash of x is x cubed plus 4x squared. So that this is just another way of writing dy dx. So we know the derivative, and they've told me that when f of 0, when x is 0, y is 0, so they're pretty much given me a point there. And they're asking me to find, this is like find y equals, or the rule, whatever you want to say, so f of x. So we're going to go about it by using the antiderivative. So we do x, we do add 1 to the power, and we divide by that. And then we do the same. So we've got 4x squared, we're going to add 1, and we'll divide by that number. And then we've got plus c. So if we tidy that up, we're left with x to the power 4 over 4 plus 4x cubed over 3 plus c. Now we're going to use, to find c, we're going to use that point, that we were given, which was 0, 0. So where we see y, we put 0, and where we see x, we will put 0. Sorry. So we see that c is actually equal to 0. So we can now safely say that the formula, or f of x, is actually just x to the power 4 over 4 plus 4x cubed over 3. So we get our final answer like that. Okay, if the gradient, I'm doing the second one, if the gradient of the tangent at point xy on a curve is given by 5x, so they're telling you that dy dx is given by that. That's like, it's another way of saying, because at the tangent, if you had like a curve and they're saying at that point you can find is given by that, that means it's the same thing. We can find the formula, or it's the same way of saying the derivative, and it passes through there. So we've just been given a point, find the equation. So we're going to find the equation. So we're going to add 1 power, and we'll divide by that power. So 1 plus 1, because that's like a 1 there, and plus c. So we get y equals 5x squared over 1 plus c. And then we'll use the point. So using 6, 6 to find c, we're going to say 6 equals 5 times 6 squared over 1 plus c. And okay, so we get 6 equals 180 plus c. So then we can just say 6 equals 6 minus 180 equals c. So you can say negative 174 equals c. Okay, so we end up with the formula for this one is y equals 5x squared minus 174. And there we go. Okay, with this last one, just going to do another manual, and then I'll show you how you do it on the calculator. So we're trying to find y, so it'll be x squared add a power, divide by that new power number, and it'll be 2x, and it's like 1 plus 1, so divide by 1 plus 1, and it'll be plus c. So we see y equals x cubed over 3 plus 2x squared, and we could say over 2 plus c. So we could simplify that to x cubed over 3 plus x squared plus c. Okay, and then we can use the point using 1 and 1 to get the c value. So we've got 1 equals 1 cubed over 3 plus 1 squared plus c. So we end up with c equals a negative a third. If we rearrange that, so we do get the same equation. So let's have a look how you do it on your calculator. So the best way to do it on your calculator is first to define the function. So remember, to get defined, we do menu an action, and you'll get defined. Then type f of x and equals. Now to get this antiderivative symbol, you're going to press menu, calculus, and integral. Integral is another way of saying antiderivative, so if they say find the integral, that's the same thing. So you might get this symbol with the little boxes. Just ignore you don't have to put anything in the boxes, and just type the x squared plus 2x in there, and then press enter, and you should get done. Now, if you type f of x, so you type that and press enter, you'll get this part, which we know that's what we got up here, but we know there's the plus c. So then if you define again, let's define the function. So I'm going to define f of x, so menu action get define, and I'll type out this thing, and then I'll add the plus c, and I'll press enter, and that way I can just pop in the point this way. I go when x equals 1, the function equals 1 comma c, and I can find it. So you can just use solve to find that the c value. So give that a go on your calculator.